dear students, welcome to Easy BTech, your guide for BTech and beyond. We are discussing about subject signals and systems. And today's topic is inverse Laplace transform problems. All of you please subscribe, share the channel. This channel is very helpful to you. Let's start our session, inverse Laplace transform problems. So how to do problems, we'll see one by one. So problem given, x of s is equal to log s plus 1 by s plus 2. So this is a problem. Find inverse Laplace transform, means find x of t. So this is the question. This we can do using differentiation property in S domain. So using this property, x of t Laplace transform is x of s. Differentiation in S domain means d by ds of x of s. It is minus t into x of t. Minus t into x of t. We can also write inverse Laplace of d by ds of x of s will become minus t into x of t. So this property is useful. So next we need to do d by ds of x of s. That we can do, see here. First write x of s, it is like log a by b. So log a minus log b, log s plus 1 minus log s plus 2, right? Then differentiation of this x of s with respect to s, d by ds of x of s is d by ds of log s plus 1 again minus d by ds of log s plus 2. So log x differentiation 1 by x, so 1 by s plus 1. Here also 1 by s plus 2. Differentiation is over. Now apply inverse Laplace. So L inverse of d by ds of x of s is equal to L inverse of, means Laplace inverse of 1 by s plus 1 minus L inverse of 1 by s plus 2. So we know that e power at u of t Laplace transform 1 by s plus a, right? So for 1 by s plus a inverse will become e power minus a t u of t. So in the same way, e power minus t u of t minus e power minus 2t u of t, right or not? So what about this L inverse? This L inverse will become minus t into x of t. Minus t into x of t. Therefore here minus t into x of t. We want x of t. So send this minus t right side, we get x of t. So x of t is equal by minus t. So we can multiply minus sign, e power minus 2t u of t minus e power minus t u of t divided by t. Divided by t. The answer. Right? Very simple problem. We go to next problem. Find inverse Laplace of x of s is equal to 3s square plus 8s plus 6 divided by s plus 2 into s square plus 2s plus 1. So this is a given problem. Find x of t, means inverse Laplace. So this we can do using partial fractions. Directly inverse Laplace we cannot do. So we do partial fractions, then for each fraction we can apply inverse Laplace. So partial fractions we have to go. Partial fractions. So here the denominator, first I am writing x of s is equal to s square plus 8s plus 6 divided by s plus 2, and the denominator here s square plus 2s plus 1, it can be s plus 1 whole square, right or not? S square plus 2s plus 1. So here we have repeated roots, right? Repeated roots are poles. So how to do partial fractions? So totally we get three partial fractions. So it can be written as a by s plus 2 plus b by s plus 1 plus c by s plus 1 whole square. So way of finding ABC is important. So how to calculate a value? So to get a value, a is equal to the x of s is multiplied by s plus 2, and after multiplication substitute s is equal to minus 2. In this process we get the a value. So here 3s square plus 8s plus 6 divided by s plus 2 into s plus 1 whole square. So this is multiplied by s plus 2 and s is equal to minus 2. So here s plus 2 cancel, wherever s is there keep minus 2. Here 3 into minus 2 square 12, 8 into minus 2 16, minus 16 plus 6 divided by minus 2 plus 1 whole square. So here 18 minus 16 2, that is the a value. So to get the b value, this is important. To get the b value, 1 by here s plus 1 power 1. Actually we have s plus 1 power 2. So 2 minus 1 factorial. 2 minus 1 factorial d by ds of, or d differentiation of power 2 minus 1, here 2 minus 1 of x of s multiplied by s plus 1 whole square. It is multiplied by s plus 1 whole square. After that keep s is equal to minus 1. Keep s is equal to minus 1. Now how to get this b value? Let's start. 1 by 2 minus 1 factorial, 1 factorial is 1, and d power 2 minus 1 is ds, d by ds of, here x of s, write that x of s totally 3s square plus 8s plus 6 divided by s plus 2 s plus 1 whole square, again multiplied by s plus 1 whole square. After multiplication substitute s is equal to minus 1. So here s plus 1 whole square cancel. Then perform differentiation. After that substitute s equal to minus 1. Here u by v. Okay, we have u by v. So b is equal to d by ds of 3s square plus 8s plus 6 divided by s plus 2. After this differentiation substitute s is equal to minus 1. So u by v here. So s plus 2 into differentiation of this u. So here 3s square 2s plus 6s plus 8 minus 3s square plus 8s plus 6 differentiation of v, s plus 2 differentiation 1 by v square means s plus 2 whole square, right? So the numerator is u, this is u, this is v. So v u dash minus u v dash. Okay. After that substitute s is equal to minus 1. So wherever you have s, keep that minus 1, we get the b value. So here minus 1 plus 2 is a 1. Minus 1 into 6, minus 6 plus 8. Here 3 minus 8 plus 6 divided by minus 1 plus 2 whole square. So this is b value here. 2 minus 9 minus 8, 1. So 2 minus 1 by 1. So b is equal to 1. Next, c value. We can get c value very easily. So c is equal to get the c value, x of s multiplied by s plus 1. X of s is multiplied by s plus 1 whole square, and keep s is equal to minus 1. So here x of s, write down x of s, 3s square plus 8s plus 6 divided by s plus 2 s plus 1 whole square. This is the x of s, and it is multiplied by s plus 1 whole square. After that, s is equal to minus 1, substitute. So s plus 1 whole square cancel. Here 3 plus minus 8 plus 6 divided by minus 1 plus 2. Substituted s is minus 1. Then 9 minus 8, 1. 1 by 1, 1. C value also 1. So finally, x of s is becoming, we are going to substitute partial fraction values. 2 by s plus 2, 1 by s plus 1, b value is also 1, c value also 1, 1 by s plus 1 whole square. Now we apply inverse Laplace so that we can get inverse Laplace result or answer we get. So by applying inverse Laplace, apply inverse Laplace transform. So this x of s will become x of t, and this is like s plus a, 1 by s plus a, so e power minus 2t u of t plus 1 by s plus 1 e power minus 2t, minus t u of t plus this is 1 by s square, like. So we know that Laplace transform of t or t u of t, Laplace transform of t u of t, 1 by s square. Now t e power at minus at of t. So whenever you are multiplying by e power minus at, s will become s plus a. So 1 by s plus a whole square. So in the same format we have now 1 by s plus 1 whole square. So it will become t into e power minus t u of t. So this is the result. Okay. This is the result we get. Now another problem we can do, the simple problem. So this is the important problem. Laplace transform of periodic signal. The problem is on Laplace transform of causal or one-sided periodic signal. One-sided periodic signal. So very important and easy. Just consider this one-sided periodic signal. So I am taking one-sided periodic signal. One-sided periodic signal. Only on right side the signal is repeating. So and so on, like it is repeating up to infinity. So for this signal we have to do Laplace transform. The signal is, let's take x of t. So here 0, it is a, it is 2a, 3a, 4a, 5a, and so on. Okay. So how to do Laplace transform of this one-sided periodic signal? Very, very important and easy. So here amplitude of the signal is 1. So this total signal I can write as x of t is equal to, in terms of step signal, u of t and minus u of t minus a, right? Plus, so here rising, so plus u of t minus 2a. Next at 3a is falling, so minus u of t minus 3a. Okay, plus at 4a it is rising, so u of t minus 4a minus at 5a it is falling, so u of t minus 5a, and so on. So like that up to infinity. Okay. Now I am taking only this first part. Okay, up to a I am taking. Up to a, the signal is taken 0 to a. This is I am taking as x1 of t. This I am taking as x1 of t. In terms of step signal, we can write as u of t minus u of t minus a. Right or not? The same signal shifted to a. Next, the same signal shifted to 4a. So if you calculate the first cycle of this signal, that is x1 of t Laplace transform, the remaining we can write easily by applying shifting property, time shifting property. So this is the first cycle x1 of t. Its Laplace we are going to do now. That is x1 of s is equal to, what is the Laplace of u of t? 1 by s minus, what is the Laplace of u of t minus a? Time shifting property. 1 by s into e to the power minus as. E to the power minus as. Right? So this is the first one. And the second one, u of t minus 2a minus u of t minus 3a. This also we can write directly. So u of t minus 2a, it will become Laplace of that. It will become e power minus 2as minus e power minus 3as 1 by s. So I am writing this Laplace as, so I am writing overall Laplace x of s equal to, you just take it as 1, x of s equal to 1 by s minus Laplace I am applying 1 by s minus 1 by s e power minus as, the first part, plus here u minus ta 1 by s e power minus 2as minus 1 by s e power minus 3as, plus again 1 by s e power minus 4as, time shifting property, minus 1 by s e power minus 5as up to infinite. Okay, and so on. So what I am doing, just I am doing mathematical simplification. 1 by s I am taking as common for all terms. From all the terms 1 by s is common. Then we get 1 plus e power minus 2as plus e to the power minus 4as, and so on. All positive terms I am writing. Minus e power minus as plus e power minus 3as, and so on. So these are the terms we get by taking 1 by s common. Okay, so this series we can write as 1 by s 1 by 1 minus e power minus 2as. Suppose e power minus 2as is x. If you take it as a x, 1 plus x square, and so on, right or not? So 1 by 1 minus x. It is the series 1 by 1 minus x. Next, this one minus, here I am taking e power minus as is common from the second part. So you get here again 1 plus e power minus 2as plus e power minus 4as, and so on. Right or not? By taking e power minus as is common. So 1 by s 1 by 1 minus e power minus 2as minus e power minus as by again 1 minus e power minus 2as. Right? Just mathematical simplification, 1 by x 1 by 1 minus x. In the same way I written here. Now simplification, here LCM I am doing, so the denominators are same, so LCM is 1 by 1 minus e power minus 2as. So in the numerator we get 1 minus e power minus as. Okay, now the denominator we can write as 1 minus e power minus as divided by 1 minus e power minus as into 1 plus e power minus a plus b into a minus b, like a square minus b square. So here these two, numerator denominator here cancel. The remaining is 1 by s into 1 by 1 plus e power minus as. So this is the answer. Now this answer we can write as, so we know x1 of s. What is x1 of s? 1 by s minus 1 by s e power minus a. So here if you take 1 by s is common, 1 by s is common, 1 minus e power minus as, right? 1 minus e power minus a. And we have x of s, the result what we have, 1 by s 1 by 1 plus e power minus as. 1 by s into 1 by 1 plus e power minus a. So this answer how we got, right? E power minus 2as. Right or not? Both are same. These two are same. Now I am going to include this x1 of s in the place of 1 by s. So 1 by s into 1 minus e power minus as is x1 of s divided by 1 minus e to the power minus 2as. This is also same answer. So here what I want to tell is, the given signal is one-sided periodic signal. This is the given periodic signal. So here 0 here, a, 2a. So this is the one cycle of the signal. T is equal to 2a. One cycle of the given signal, or time period of the given signal, t is equal to 2a. So in the place of 2a, now the answer is, we can write as x1 of s by 1 minus e to the power minus t s, where t is equal to time period of the signal 2a. So this is the formula for Laplace transform of periodic signals. So first signal Laplace transform by 1 minus e power minus ts. First cycle Laplace transform by. This is a Laplace transform of periodic signal x of t. Laplace transform of periodic signal x of t is equal to x1 of s by 1 minus e power minus ts. Very, very important and easy. So thank you students. Thank you for watching. Please follow videos regularly. Thank you all.